Today we're going to look at a problem called twosum. In this problem, an array of integer and a target value are given as input, and we're going to find two numbers that add up to the target value and return the indices of these two numbers. So one thing we need to know here is that the input would have exactly one solution. So this makes the problem much simpler and easier to solve the problem. Now let us first take a look at a simpler and easier approach to solve the problem. In this approach, we're going to use two pointers. We're going to get the values at these two pointers and sum them up. So the sum of the two values, we compare it with the target value. If the sum is equal to the target value, then we return the two indices. Here we start the first we start the first pointer at index 0 and the second pointer at index 1. So the two values are 1 and 2, and the sum of these two values is 3, which is not equal to 9. So we move the second pointer to the next value, that is 4, and 1 plus 4 is not equal to 9. Then we move to the next value, that is 7. 1 plus 7 is not equal to 9. Then we move to the last value, that is 11. 1 plus 11 is not equal to 9. Then we move the first pointer to index 1, then the second pointer to index 2. So these two values, 2 and 4, the sum of 2 and 4 is not equal to 9. Then we move the second pointer. So here the two values are 2 and 7. 2 plus 7 is equal to 9. So here we find what we want. So we return the indices of these two values. So the output is 1 and 3. The approach we just have discussed, and we use two loop here. This is the first loop. Then we have an inner loop. Then we get two numbers using these two index. Then we compare with the target value. If the sum of these two numbers is equal to the target value, we just return the two indices. And here we can see that we use two loop, and the time complexity for this approach is n square, so which is not the optimal time complexity, and the space complexity is of 1. So in the second approach, we're going to find a way to reduce the time complexity. In this approach, we're going to use only one pointer, and we're going to use hash map, and we call the name visited. We're going to use the value and index pair we have visited. So we're going to start at index 0, and we get the value of that in the current index. Then we find the complement of that value. The complement of that value is the target value minus the current value. So here the target value is 9 and the current value is 1, so 9 minus 1 is 8. Then we search this complement in the hash map. Here we don't find the value in the hash map because we just started and the hash map is empty. So we store the value and index pair in this hash map. Then we move on to the next index, that is index 1, and the value at index 1 is 2. So 9 minus 2 is 7. And here we search again the complement value, that is 7, in the hash map, but we don't find it. So we store the value again, then we move on to the next index. So here the value is 4, so 9 minus 4 is 5, and we don't find 5 in the hash map. So we store the value and move on to the next index, that is index 3. Here the value of index 3 is 7. So 9 minus 7 is equal to 2. So when we search this complement, the value 2 in the hash map, we find it in the hash map. Here we can see the 2. So we find what we want now, and we find it now. We have the solution. So what we need to do is we get the current index and the index of these two, the index of the complement. Then we just return it. So this is the output we want. In this approach, the time complexity is n because we loop through this array. It means there are n steps involved, so the time complexity is n, and the space complexity is also n. The reason is that we store n number of items in the hash map. And now let us implement the approach we just have discussed. I will first define the hash map. Here I'm going to use only one pointer, so I'm going to use only one loop. I'm simply going to loop through the array. Inside array, I'm going to find the complement of the current value. That is a target value minus current values. So I'm going to search if this complement value exists in the visited hash map. So if the complement exists in the visit hash map, then I'm simply going to return the index of the current index and the index of the complement. If the complement does not exist in the hash map, then we are just going to store the value. We're just going to store the values, the current values and index pair in the hash map. Then move on to the next index. So here's the solution we have implemented. So let's see if this work as we expect. See, it is accepted. So the solution we have implemented is correct.